Thanks. This is my first ARC conference, so I'm happy to be here. Thanks for everybody attending. I work for Phillips 66 refining. We've got 12 refineries in the U.S. and one in Humber, the UK. MRO I'm not familiar with, so I don't ever get involved with that refinery, but I do all the others. I work at I'm localized at the Borger facility. So we're about, well, right there in the panhandle of Texas. Our throughput, somehow I must have deleted how much refining we do, but it's about 156,000 barrels a day and 22,000 NGL. So we had increasing issues with an obsolescence, end-of-life support. We had hardware that was dying out in our tank farm. So this is a project to discuss all the obsolete. They were a mechanical L&J Shannon Gears tape system that was tied to the roof or a float and a geared system. And so that they're like 40 years old, 30 years old. So they were dying. We couldn't get parts for those anymore. About the late 90s, there was a project that took those gauges through an L&J highway-based system to RTUs and brought in that RTU code. They customized inside the Bristol PLCs, had a customized layer that took the L&J code and radioed that back to the DCS, and there was a serial communications module on the back end that pumped that into the DCS. Then the blending software, similar to the previous deal, our oil movements and storage system it monitored the tank gauging. But so we tied both of these into a multi-phase project. The OM&S software was really end-of-life support for the demographics of the engineers that supported the back end. They actually talked the engineers into staying longer, postponing their retirement to help get all the customers off this previous system. So I work on the capital projects team, and our long-range plan, so following our capital project rules, I have to come up with 5-year and 10-year long-range plans. And so every project I come up with, it takes me a year to work it into the capital plan, and then develop the actual project itself. So it could take me 2 years to actually get an AFE approved to do anything with. The other rule I've got for our refinery anyway is anything I put in, I want it to be supported for at least 15 years. So any interim solution or stepped phased project, it has to be compatible with the final end solution in mind. And obviously I don't want to take the plant down while I'm doing it. So the multi-phase project we came up with, we evaluated multiple methods, hardwiring new transmitters all the way back. We're spread out over a large area. So some of the solutions we evaluated cost too much, that kind of thing. So we ended up evaluating wireless, and we actually ended up going with a wireless technology. So the two big players out there that are campus-wide, enterprise-wide instrument networks were Huot and ISA. And in that evaluation for Borger, these are the reasons I really chose to go with the ISA one. Oh, sorry. To go with the ISA. But the biggest reason is this over-the-air provisioning and doing sensor upgrades and radio upgrades. It turned out to be the biggest benefit for us in Borger. All these other things, we've increased reliability, the security level. So the whole conference here over the past few days has been security focused. And there's security at multiple protocol stack layers inside the ISA 100 that I think is better than some others. So this is why I chose ISA 100 for Borger. I'm part of the corporate wireless lead for all of our refining. So we evaluate every refinery can put in whichever system they want, but we have to evaluate it properly. And some of our refineries are Huot-based and some of us are ISA-based. So one of the things to prove the case study was I come up with a pilot program to test first 10 tanks, and then the solution set wasn't big enough, so we increased it to like 20 tanks. And then once the concept was proven, we finalized it to go plant-wide. So where we're located in Borger, the terrain is kind of nasty, lots of canyons and ridges and things like that. So every location, it was a flat spot. So if we looked at a topographic map, the only flat spots around that actually have pieces of tank farm. So this left portion is the north side of our refinery, and this right half is the bottom half. There's another off-site, another tank farm that's 5 miles away from these locations. So we're spread out. So that was one of the biggest challenges we had, and one of the supporters of going wireless. All the colored lines on here are, so rather than have one huge wireless system, I busted it up in quite a few pieces so that I wouldn't have all my eggs in one basket, even though it's fault tolerant and redundant. So some of the challenges we had so there's in these three columns here, oops, sorry boys, in these three columns here, I'll talk about it some, but the old kludged customized system had where there's those blue lines there, there's customizations that wasn't commercial off-the-shelf components throughout that whole application layer that you're looking at. So I needed to get from that mess to commercial off-the-shelf straight through and collapse all that customization into a better reliable system. So we discussed the L&J tank gauge had a custom protocol conversion inside the PLC, a Bristol PLC, and then it went from a BSAP protocol through into our DCS system, ICS system. Since that was customized there, we had to customize the templates inside the communications module to fit those templates. And then our OM&S package on top, the blender and the oil movements and storage, it was really to be designed to be bolted onto a process manager system. And it was a Honeywell-based system, so it was meant to bolt on the Honeywell system. And our guys force fit, bolted on, and customized and emulated HPM points inside our application module. So you can build custom data segments, that kind of stuff. So the points, it was kind of invisible to the OM&S layers that it wasn't working with an HPM, but in reality it was going through all of this conversion and slow serial system. So one of the phase steps in our pilot test was to prove I could replace gauges out at the instrument layer, collapse, getting rid of the old RTU methods and the old serial system while I'm doing it, one gauge at a time, of course. And so this new Experion, so one of the benefits are these devices down here, one of my requirements was it needed to be native to the DCS. So didn't have to go through an OPC integrator, no communications software component to get it to the operator. So all of these, if they have diagnostic problems or they're multivariable transmitters. So if they have any issues, the operator gets an alarm either on system status or point alarm. So having it in that ESVT, so this old system in this intermediate step though, I did have to use an OPC integrator to pump it down to the same tag.parameter locations the old communications module pumped it to. So this whole protocol stack, all the OMS software that was running was unchanged. It just kept on running. So then the next step was one of the other requirements operations had was I had to cut this entire system over in a 48-hour period when I got to the OMS side. So we deployed since the newer system we were moving to was also the newer BMA system for Honeywell. It bolts directly onto the C300 controller, their latest controller. So the blending header, all that kind of, so all these gauges, being native to the Experion, plugged right into the Honeywell. So we pre-staged new RTUs with Universal I/O out next, right back to back with the old RTUs that were PLC based, were now C300 I/O based. All the cables, everything was already sitting there ready to go in a 48-hour period. All we had to do is disconnect all the EMVs and booster pumps, things like that, wire it up, loop check it, and we fired up a test blend, and it ran beautiful. So that's how we phased through all those little requirements. One of the things as being a corporate guy or corporate involved with our corporate leads was when we were rolling out our pilot, a lot of our other refineries were also testing wireless instrumentation. So the wireless awareness was kind of nasty. So we developed a sub-team. So there's a couple of guys at each refinery that we meet monthly. We developed some guidelines, standards, required best practices, basically. And some of the refineries said, well, it's just a best practice. We don't really have to follow what you're asking us to do. So a couple of years of that, we rolled it into a required standard is how we termed it. And they had till the end of last year to start meeting our required standard. But what I want to discuss here is, so in the vision, one of the things that I require every refinery to have is a wireless management manual or a vision and where they're going to roll things out. So if we're going to deploy wireless, Wi-Fi, and instrument networks, so the backhaul meshing between APs is in the 5 gigahertz range. There's backhaul bridging. So if you remember, the refinery is spread over a long ways. So we have some fiber to some route access points and backhaul bridges as a redundant or fault tolerant pathway from the far end locations. For Borger, I wanted to reserve the 2.4 gigahertz space for instrument networks. Basically, all these. This basically is 1/4 second cycle in the ISA schedule of scheduling transmitters to talk. In the 2.4 gigahertz space, you've got these 15 usable channels, 16 but in our case, both Emerson and Honeywell, neither one use this channel 26. But anyway, in that 2.4 gigahertz space, in the Wi-Fi range, there's these 3 non-overlapping channels. And also, if you're deploying much Bluetooth, there's 80 channels of the Bluetooth in the same 2.4 gigahertz subspace. So in our Wood River facility, they also deployed a Honeywell ISA 100A site. Their batteries all of a sudden their batteries in their wireless transmitters were dying and not lasting a month. So when we have the Fluke Air Magnet tablets, and we can go around and sniff and do our own surveys. While we were troubleshooting this problem, there was a contractor that had come in, construction, it was an embedded construction company on this site, and they deployed an access point inside their construction trailer. And each of these are basically a 20 megahertz wide throughput channel that you can, in Wi-Fi wise, you can bond 2 together to double that throughput. And in this one complex trailer, they bonded, this one AP was bonding these 2 together in a 40 megahertz and these 2. So basically they wiped out the entire set of all the subchannels for the instrument network. So what happens in that case is these transmitters that are supposed to be low powered and only wake up on their 10 millisecond scheduled cycle, one of these little squares, to wake up, send their packet, and then go back to low power or sleep mode. If they don't get good acknowledgement back that their packet was made, they stay alive and trying to find gateways. You know what I mean? So it's fault tolerant, so there's multiple APs out there. So it's always there's a table of APs that a wireless device will maintain in its list. Even though the wireless gateway manages its pathways, and you're going to take this route to get back to me type thing in the backbone routers, so the transmitter, if it can't see that path, either of its assigned paths, it's going to stay awake and it drains that battery down. So I use this to help train all of our refineries to come up with some kind of plan to manage wireless. So for Borger, like I was saying, I want to move. So I have a future Wi-Fi app today across all the tank farms in the refinery. I have Wi-Fi is disabled, so we don't have any Wi-Fi apps at this time. But this year, I'm developing our first mobile station with the operators, and we'll follow up with another survey. So that was one of our requirements corporate-wide, is anytime you deploy a new application layer throughout your wireless infrastructure, you have to do another wireless survey and make sure you manage it properly and assign it. So in the case of the 2.4 gigahertz space, so what you do is you put APs so that they're non-overlapping channels and alternate and tile it. In a nice 5 gig, there's more channels available than this, but these are the non-DFS. So there's inside the Cisco APs or any AP, if it senses power on like a radar, it shuts itself down. So it'll completely shut down the AP and stay, I think it's 30, is it 30 minutes? I think it's 30 minutes before it comes back up and tests and starts talking. So for Borger, I've assigned, these are the only ones Borger's gonna use. And so I've got to manage those 9 tiles to do these functions across Borger. So I still have yet to do the actual channel management in every one of those locations back here. So basically every circle you see here, when I first did my deployment and I was thinking about it using the 2.4 gigahertz space, those were my tiled colors for the channels. That was before I really dug into the instrument networking of the 802.15 standard and realizing that was probably going to be a mistake. Because we had backhaul bridges, which would have taken up one of those 3 non-overlapping Wi-Fi channels, plus all the instrument and Wi-Fi apps in the future. So there's no way I could have got that to fit. Okay, so when we did our first pilot, we of course used Honeywell to help us with our wireless surveys and the initial system design. We managed our own construction contractor, but then had Honeywell come back to do the actual configuration of the wireless system. So there were some lessons learned there. In when we decided to finally go plant-wide, we ended up utilizing our vendor all the way to involved in every step, so we closed some of those gaps that we ended up with. One of the benefits we see, as I mentioned before, all the devices are native to the Experion. So one of the things about ISA is you can tunnel other protocols through it. It is one of the nice features of it. So we've evaluated some of the vibration vendors, both GE, I can't remember the other one. Anyway, you can do a lot of analytical stuff, and they tunnel those large packets through the ISA instrument network. So for Borger, I'm not going to allow any, because it's going to eat up a lot of that scheduling cycle here. So if I start tunneling like some of the critical machines, so like a Bentley 3500 system, which you'd normally have a wired system for, there's solutions in here you can actually tunnel that through. So you'd be tunneling multiple, you'd be eating up your schedule. So for Borger, since we deployed wireless or started piloting it, I've got requests constantly, we need a transmitter over here, we need a transmitter there. So if it's within 100 feet, I tell them, you better wire it. We're not going to go wireless. And I really don't want to do any tunneling of any analytical software through this ISA network, even though it would support it. And so I also want anything I deploy, I'm going to really want it to be native to the DCS, or ICS, I mean. Oops, sorry. That way the operator gets the alarm, rather than go up to a proprietary, tunnel it through, go through a gateway to a server, unpacketize it, and push it back with an OPC server. I just think that's not a good way to go. So I'm going to try to stay away from doing things like that. One of the things we did, we remember those 3 columns of how complex that we completely made it maintenance friendly, user friendly. It's a lot more reliable. It's easy to add. So we've increased that reliability. The speed of the data. So if you remember that old serial kludged system and all the protocol conversions, we were point limited. We couldn't add instruments anymore without slowing down and slowing down. We were down to, it was like a minute update on all the values. Any EMV or booster pump or pump starts, that was on demand and went out immediately. But as far as PV values updating, it was really super slow. Now that the way we installed it and cleaned it up with that small stack application layers on the far right of that previous screen, now we're down to seconds. So the large temperature values, like the large tank temperature level, those are still scheduled in the ISA table at like 30 seconds. Those don't change very much. And so every instrument, we decide how often we're going to publicize and update the operators. But all the real live values is really second update rate to the real board operator. It doesn't go through all that conversion. And so tracking how many blends just straight at the ICS basic process control layer, we've increased from 40 some blends a week to 50 some blends a week. So we got an 18% improvement just in the basic instrument layer. So we got that improvement. And then having the new analyzers online and closing the gap on the giveaway and that kind of stuff is also a big financial gain. But I didn't want to point any of that stuff out. I was really focusing on the ISA instrument. So one of the other projects I'm rolling out this year is the Wi-Fi apps for mobile operators. Oh, sorry, keep going too far. So I kind of alluded to wireless awareness. It's been a good thing that we're educating all of our wireless folks that want to deploy across our company. The other thing that's been really beneficial is partnering with the vendors. So I've actually, it wasn't just Honeywell that we've partnered with. I actually, for the guys that are Huot, I partnered with their development engineers also and learned their systems, that kind of thing. So this is the most important, or one of the most important things I wanted to get across to all our refineries. And then having the maximum density of transmitters. I really expect it to grow to really in the thousands, but the only way I'm going to do that is managing Wi-Fi off of, keep the Wi-Fi channels dedicated somewhere else and leave that 2.4 gigahertz range for instrument networks. But that's all I've got. Thank you.